Well, hello fans. This is Texas Tim continuing my project to grind through LeetCode. As you can see, I've got some different seasons where I've been more involved in grinding and less involved, depends on what's going on. And I hope that I'm beginning to do some more grinding, and I'm happy to have you along for the ride. So let's see where I'm at, 19,000. And let's go to the problems. I've cleaned out the easy. Let's double check. Right, so there's no easy ones available under algorithms, which is what I'm working on. So let's move on to medium. And I like to sort from easiest to hardest. So that would be this one. 1852. 1852, distinct numbers in each subarray. Interesting. Given an integer array nums and an integer k, you are asked to construct the array ands of size n minus k plus 1, where ands is the number of distinct numbers in the subarray. And what is n? It's I. I am having a bit of a tricky time wrapping my head around this one. Array ands of size n minus k plus 1. Distinct numbers in the subarray. Okay. Okay, so we've got overlapping subarrays. Oh, okay. Okay, I gotcha. I gotcha. Okay. So if the input array has a size of 7 and k is 3, then the output will be 5. So nums length minus k plus 1. Okay, got it. And then that's what we return. Hey, we're halfway done. I just have to fill in the middle bits. Let's do it. So we're going to, I am thinking, got a couple of ways we could do this. We could do nested loop. We could have an outer loop that goes from index 0 to index nums length minus k, some of that. And then the inner loop would be to run out to the plus 0 to the plus k offset within, of that outer loop index. The big O of that would not be necessarily super great. Alternatively, sometimes you can sort of keep track of the current subarray of interest by adding a number to the front and taking a number off the back. Let's see if I can do that. Distinct numbers. That could get a little tricky, like you might use a set or something to get distinct numbers. But then it gets harder to remove the the element of the subarray that's leaving, to make sure you remove it without removing every element of the like later elements in the subarray that would have that same value. Because you lose information when you put things into a set. You lose info like, well, how many of this number were there to begin with? So what I sometimes like to do is just make a naive solution, just get something out there, even if I know the big O is not optimal, but it gives us a starting point. Let's try that. And sometimes to remind myself, I'll even say naive solution. So it's going to be, hey Scotty boy, that's my dog. Scotty boy, come in here. He's kind of deaf, so he doesn't mind the fireworks too much. But I may have to cut this video short so I can go snuggle with him. Alright, so this would be the outer. And then, minus K. Off by 1 errors, man. Frickin' A. Okay. Plus I. Okay. I had to use my fingers to make sure the num's length minus K was right. I mean, off by 1. That's like the bane, right? Those fence post errors. All right, now inner loop. J equals 0. These are like the offsets of that variable I index. J equals 0. J is less than K. And you can see we're getting, this is going to be some huge big O here. Let's set integer Subarray equals new. This is going to be terrible performance. Actually, this is going to have to go out here. Okay, now we go through Subarray add nums I plus j. And then ands I equals Subarray size. Okay. What will return? Let's take a look. Look for stupid mistakes like missing semicolons, incorrect fences or braces. Let's see what we got here. I equals 0. Yes, I could just hit run code and let the compiler catch my mistakes for me, but I like the practice of inspecting my own code being my first QA, and it also gives me a chance to catch my own mistakes instead of offloading that or delegating that to a computer. Especially in an interview type situation, you want to demonstrate that you know how to spot things, you've got good attention to detail. Okay, well, let's run it. Dang it. Alright, what happened? Ow. Doing some spaghetti action, man. I figured it was an off by one, but like I did not actually like mentally grok that that was what it was. I I cheated. I did. I looked at the output and saw it wasn't catching it, so I just extended it by one. I feel a little bit dirty. All right, well, let's submit it and let's see where we land performance-wise. And actually, yeah, I should have looked at the constraints. Look at this. 10 to the 5th. So that's a that's a no-go. That is not going to work. We're spending a lot of time adding elements to a set. So how about okay. So the code is correct, but it is severely underperformant. So naive solution is not going to work. Let's try to maintain a list. A list representing the current subarray, and the interface we can make list, and the underlying data structure, let's do linked list, and that'll be super easy to just delete the first element and then add an element onto the tail. So we'll just be deleting the head, adding the tail. And in terms of counting unique elements, I'm thinking we just dump it into a set and count the size and, you know, retrieve the size property. I think that would be, let's try it. So instead of adding the whole subarray each time, of which length of subarray minus 1 would be numbers that were in the previous subarray, well, length of subarray minus 2. Only the, yeah, because we're taking one off and adding one. This way we're preserving a lot of those numbers, and that should save us some cycles. So list integer cur subarray equals new linked list diamond operator. And I think I have to prime the pump here. Because inside the loop is going to be code to just take off the first element and add the next one. It won't have actually the code to add in the first, to populate that subarray for the first time. So we'll do that. So this is, we're priming the pump here. I0 i's less than k plus I. Subarray add nums I. Okay. So we've got our first list. And 0. Oh, before I forget, I'm going to forget that. And 0 equals new hash set integer cur subarray. I think that'll work. Let's just make sure that this kind of composite. Okay, good. Okay, and now we want to, and I'm going to storyboard I'm going to pseudocode it with comments. So remove first element, add new element, store size of set in ands. And I don't deal a whole lot with linked lists, so let me just take a gander at the API here. Probably like a remove. Yep, remove and an index. Good. So cur subaway subaway remove I minus 1, and then curse subarray add trailing index equals 0. I kind of like this. I'm sort of making this up a little bit as I go. Remove 0 and add, so this will be k plus 1. So we'll remove, I like this because the code documents itself, right? So we're going to remove trailing index and then decrement that. And then add leading index and increment that. And then we'll do our fancy, and actually, let's see. Well, that's fine. This will be I. Huh. I kind of like that. Trailing index and leading index. Let's do add next element. Alrighty. 0 through k. So I think that might actually be that. Index out of bounds. Some of those fireworks sound like gunshots. Okay, index minus 1. Oh, oh my goodness. No, the trailing index is also increasing. Heavens. Dear heavens. Now the reason I'm using two indices, because I could just have a single index and then calculate the offset every time, but I'm just thinking of all those additions. You know, like we could just make this, this would be I minus 1. Actually, no. We're going to always remove the first one. I'm like rubber ducking right now. I'm like talking to my monitor. And it's, oh my goodness, a little bit embarrassing. If we were working on the input array itself, then yes, our leading and trailing index would be moving like that. But we're doing something a little bit different. So we're going to remove the front, the first one, and then add the next one, which will be nums of the leading index. Oof. Let's run it. Good. But is it performant? Let's see if we can even get on the board. Ugh. Still not. Let's see how big this thing is. View all. Yeah, that's a pretty big input array. Okay. Well, it is medium, but a lot of people did get it right. Number of distinct elements. Let's think. Let's have ourselves a think. scintillating watching, isn't it? I am a little bit stuck. Was there any hints? Let's see. Constraints. Let's look at a hint. Frequency map of the elements in each window. Frequency map. Okay, so here I'm operating on a brand new. I'm having to consider every element in the subarray every time. Okay, that's good. Frequency map. What are the constraints? So the values could be up in the up to 10,000. Sorry, am I bouncing that? I'm bouncing a little bit. Sorry. Okay, this might be a little bit of a naive frequency map or frequency table. Did I say map or table? Yeah, I call it a table. Yeah, not that big. A lot of space. Oh yeah, map would be better. Yeah, okay. Integer. Frequency map. Hash map. Okay. And we will initially populate frequency map. I like to use markdown formatting in the comments. Partly just helps me to, see the variables. Okay, so frequency actually. For the initial population, let's do merge. The key is nums I. Initial value is 1. What is this? I'm going to have to address that later. Life happens even when you're coding. And then, okay. And that will give us our initial map. And I guess I'm going to make a little function. Oh, actually we could get a key set and get this size. Frequency map, key set. Right? Let's verify that the key set just returns a regular old set. Yeah, so Boomsies. Okay. We're not really gonna do that. So here now we are gonna remove the previous. And what we're gonna from frequency map. Remove the first element from frequency map. And we know that it is, so I don't have to do some of the guard clauses or checking, because we know that the I-1th element must have been in the map because we would have added it earlier. So frequency map get I-1. Okay. And then subtract it. Is that how that? No, that's not the words. Actually, I wonder if I can do merge the I-1th. Well, the nums I-1th element -1. I think that should work. And if frequency map get nums I-1, that was terrible, is 0, then remove it, because we don't want it to count toward the key set size even if the value of the key value pair is 0. Well, especially in that case. And then ands 1 equals, and I'm going to delete that code below that. That's cruft, as they say. Okay, and this will be ands I. All right, let's see what we got. So we got our frequency map thanks to the hint. I usually try not to use the hints, but I was really stuck on this one. Frequency map, and then populate it initially, and then store the first value in ands, and then we run through I have to add the new number. And there's a lot going on. I also need to update the for loop parameters, because now I am going all the way up to the end. Less than, there we go. Merge nums current one. And then we grab the key set size. I think I'm gonna start at K. There we go. Kind of embarrassing, revealing just how much editing goes on when I'm writing an algorithm. All right, initially populate. And then here, index. Let's close that up. I think it is going to work. Let's give it a shot. Run code. Yes! Oh my goodness. But is it performant? Well, I hope so. We use the hint. Let's see. Wrong. Wrong. Okay. Let's do some debugging. Why not? Let's do some debugging. That's why we pay for the. That's why I pay for the premium. All right, I added it. Now let's debug. Can I get more room? No, that's not adjustable. Okay. Let's see what we got here. Nums is that. K is 3. Okay, so these are our, this is what we're given. Ands is our empty answer. Frequency map. For the first 3, there's 1, 1, 1, 2, and 1, 3. Okay, and we're going to do the step over. We got step over, step into, step out. What's this? Oh, continue. We'll be doing step overs. I'm not averse to a little printf debugging, or in this case, system out println. But the debugger, it's very handy. You don't have to set up all these, all the print statements for all these variables, and probably just looks more professional, to be honest, to show familiarity with the debugger. So let's go through. I want to kind of. Oh, I hope that's not too small. Is that too small? Oh gosh, what am I doing here? I wanted to see the whole loop in there. Oh, okay, maybe that'll work. Okay, step over. So we added 3. I equals 3, so 0, 1, 2, and 3. See, we're actually removing okay, there you go. So I'm going to call this trailing element, and we are removing I minus k, and then k, and then k, I minus k. That's how we debug. We write, and then we check, and we find out what we got to do. Let me run it now. Okay, so it is running and working. Now let's submit. Hooray! Nice placement right in the middle. Not too bad. Time complexity ON, since we traverse the input array once. Space complexity, I guess, is N, since we maintain a frequency table of input. Well, hold on. It is K. Yeah, the frequency. Well, the table, of size less than k. If it was all distinct integers in the subarray of k elements, then the frequency table would be of size k, but if there's any duplicates, then there'll be fewer entries of size k. I'll do less than or equal to k. I probably should learn that better. Okay, so we're on the board with something approaching performance. So can we make it better? Add next element to frequency map. Record okay. Let me run it again just to see if we get anything significantly better. No, it's about the same. Let me update this memory usage. I like to get a sense of where it is. It's probably not going to vary very much, but I do like to sort of keep track of the best I've seen, the best score I've seen for memory and for runtime independently. All right, I'm not sure. Let's take a look. How could we improve it to get it up higher? Okay, we're using this frequency map. We could kind of roll our own frequency map with a giant integer array and then keep track of the number of elements of that array that we're actually using. We'd have to keep track on the way, because we wouldn't want to have to do an inventory of that giant array. We'd want to be maintaining that as we go. Let's see. Kind of making our own little map. Oh, why not? Let's see. Map. Why not? How many? What's the value range? $10,001. Now we gotta make kind of a little API. So add to map. What is that? Add. I like add to map. Remove from map. Int get key set size. This would be returning a variable that we're maintaining called key set size, which is going to be out here. Key set size equals 0. All right, so when we add to map, first we check, do we have anything there already? So if, and what's the name of our map? It's just map. So if map of n equals 0, then woohoo! Not only do we increment the count there, which really, we can just say it equals 1. And then we increment the key set size. Otherwise, and what I like to do is to put a comment after the else to indicate what it is that, what condition. So it's not 0. If it's not 0, then we just increment whatever's there. And then we return. I mean, we could do that. I see that I'm kind of duplicating some code here. I'm saying map, increment from 0 to 1, and the versus incrementing whatever's there. So why don't we, so here, if we know this is a number we haven't been tracking before in our map, then we do want to increment the key set size. And then in any event, we're going to increment the value there. So it could be going from 0 to 1, or it could be going from any non-zero number to, +1. So remove from map. Now here's where we could do some error checking, boundary checking. Because if you remove from map, we could verify that there's something there to remove and throw an error if it doesn't. I think we're going to do a little quick and dirty here. And I'm going to trust that any number I'm removing is legit, probably was added before. So remove from map. So decrement it there. And then got our little reverse check here, checking at the end instead of the beginning. If map n is now 0, then decrement the key set size. Okay. And then here we can get the key set size. So that's our little, these are our methods for our little API. Here's our underlying data structure. We need that as a important variable to keep, and turn the debug off. So now we don't need this guy anymore. And now we're going to add to map nums I. Yes. And then ants index, that's fine. And then we're going to get, what's the get key set size. Why not? Why not roll your own map? Why not? Okay, now here. And look at this. So what we're removing is this guy right there. Let's comment those out. Remove from map. That one. And then we're adding this one. I do like how, because we made our own methods, this code is super self-documented, and I do like that. Add to map, and now we get key set size. Boom. And I'm feeling so confident, I'm just going to delete the old code here. Although it could, well, if it ends up that this code is less performant than, using the inbuilt map, hash map, then I can always, LeetCode lets you go back to a previous submission. So I could always grab one of these previous ones and get my code from there. No problem. Let's get rid of this 2 and this, so we have nice clean code. All right, let's run it. I think it looks good. So it did work. And we're using a map, So the performance should be not too bad. Array index out of bounds. Okay. Oh, that's 10 to the 4th. Eugh. That's 10 to the 5th, right? Okay. Ooh, I like that speed. I like it. I like it. Very, very cool. Yeah, that is not too shabby. I'll take that in a heartbeat. Still O of N, still O of N. And our map. Actually, let's call it frequency table. So it's a little bit better self-documenting. And the other nice thing is I don't have to change anything in here because I've got it nicely abstracted away. So I just got to go down here and make sure I update these guys. And then key set size. Let's run it again just to make sure. Submit it again. And it's all comparable. Alrighty, well I think because I rolled my own map, I think it is worth adding to the discussion over here. So let's go over there. Sliding window, hash map, that's cool. So they did use a hash map. Let's just take a little look at this person's, yeah, hash map. We did that one. But I mean, I did that and I found that it was like solidly in the middle, right? It was like 50 beats 50%. So this is, I think, a little bit better. Let's see, Java and 8 milliseconds beats 91. Yes. Uses, do people still say hand rolled when you do your own data structure or anything? Let's see. Hand-rolled algorithm, like roll your own. Hand-rolled loops. Hand-rolled. Let's see, 8.5 million. I wonder, do people hyphenate it? 8.5 million versus just 1 million. What about roll your own? Where's that fall in? 2 million. Roll your own algorithm. Roll your own crypto. That seems to be a pretty common collocation, is to say roll your own in reference to cryptography. Although people also say that in reference to user authentication and random numbers. There's actually quite a few areas it seems like people say don't roll your own. Hand-rolled frequency table. Maybe I'll hyphenate it because it's, get rid of that little squiggly red line. All right, let's post it. Woohoo! I hope that helps somebody. And it also shows that you can write your own data structure and API for the data structure if you need to get some performance. Boom. All right. Hey, thank you for watching. And that was a lot of fun. And I'll catch you the next time. Bye-bye.